All right, so an arithmetic sequence is a list of numbers that have a common difference between each successive term. So if we look at that first list, we're looking at patterns. So we have 2, 4, 6. What would be next? 8, 10, 12. What's the common difference between each term? 2. In other words, we're adding 2 each time. -5, 7, 19. Sometimes it's easier to think about what that common difference is. What's happening? So it's increasing by 12. So what would be the next term there? If you add 12, 31. Add 12, 43. Add 12, 55. Dot, dot, dot. Notice it has a dot, dot, dot because this pattern could keep going on and on and on and on until you get bored with it. But this one's written kind of weird. R plus 15, R plus 8, R plus 1. What's happening on this pattern? Yeah, the R's are the same, but this number on the outside is decreasing by 7. So sometimes the common difference is that we're actually subtracting each time, or adding a negative. What would be the next one in this series? Sequence. R minus 6, subtract 7, R minus 13, and the next term would be minus 20. Okay, so the first term, we use the notation U sub 1. That subscript determines the position the term is in. Second term is U sub 2. Third term would be U sub 3. Fifth term would be U sub 5. That little number means which term we have. And we write the difference as D, because, well, we're not creative. So there's one way to write this pattern, and I'm going to use one of these to kind of show how this works. So let's take this pattern. U sub 1 was -5, right? On this second sequence. Oops. Yeah. The second term, the way we found it was by adding that difference of 12, right? So if I took the first term plus 12, I would get the second term. To get the third term, I could just take 7 and add 12, but really what's happening is I could do -5 plus I've added 12 twice so far. Would this work and give me the next one as well? 24 and a -5 would give me 19. To get to the fourth term, if I was starting with the first one, how many times would I have to add 12 to get to the fourth term? 3. 36 and a -5 does give me 31. Now the reason we're doing this is because it's going to help us if we had to find, what if we wanted to find the 20th term? Alright, so let's think about this. If I wanted to find the 20th term, and I really didn't want to list out 20 terms, for the fourth term, we had added 12 how many times?
Oh, it would be 19.
It would be 19. It's actually going to be one less. 19 times that common difference. Does anybody find out what the 20th term is going to be? If you've got your calculator handy, -5 plus 19 times 12. 223. See, I wouldn't want to list them all out until I got there. Could you, though? You could. IB's okay with you doing that, but I really wouldn't want to do that. So if we compare this setup, which is going to be on your formula sheets, to find any term, you would start with the first, plus, and then notice this is n minus 1, because we've added only 19 to get there for here. So it's 1 less than that position times that common difference. So here, we find the 20th term. So this means to find u sub 20. Here's my first term, right? U sub 1 is going to be negative 11. What's the common difference for this first example? What's being added each time? 9. Now, I could write out 20 terms. I don't want to do that. So, to find the 20th term, we're going to start with the first term. And I need to add, how many 9s am I adding? 19 9s to get to the 20th term. Remember, this is the first term, so we'd have to add 19 of those to get to 20. So what would the 20th term be? That's hard to say real fast. 20th term. Do anybody, what is it? 160? I'm believing you. I'm not using my phone. Okay. Alright, so find the 100th term of the next pattern. What's the common difference of the next pattern? 4. So I heard 4 plus. Wait, is it 4 plus?
No, oh, no.
What's the first term?
Maybe 1.
We always start with the first term plus 4 times 99, because we need 99 of those 4s, which is is that 97? No, 397? 397? Thank you. Now, don't get confused when they say find the formula for the nth term. That just means to plug in only the stuff we know. So u sub n equals, what's the first term? Plus n minus 1, because I don't know what n is yet. And then the formula says times d. So what's the common difference? What's happening on this one? Ah, this one's going down by 9. So you'd actually be subtracting each time. Now, since we didn't have a specific n, this is what they mean when they say find the nth term. You're just writing down the formula you would use. Unless they gave us a specific number, we couldn't do anything else. All right. On this next one, they give us u sub 50, which would be the 50th term. They give us u sub 51 and u sub 52. We've got to actually work backwards to find u sub 1. Do we know anything by knowing those 3 terms, though? Well, isn't 50 and 51, aren't they right next to each other? So what's the common difference? Plus 5. So, let's see. How about, what was that formula going to be? U sub n equals u sub 1, right? I'm just going to write down the formula from the other page real fast. What if we plugged in something we knew? Plug in a term we know. Which term do you want to plug in? 50? Okay. So if I'm using that term, u sub 50, we know it's 6, right? It equals u sub 1 plus, what would I be multiplying times the difference? 49 times 5. Could we actually solve for u sub 1 now? Can you find 49 times 5? $245. So to find u sub 1, we would subtract 245 from both sides, and u sub 1 equals negative 239. Okay, thank you. And it's okay to have a negative number. The next one. Oh, they're not so nice. They didn't give it to us where the terms are right next to each other. Ah. Okay, so 25 to 70. Let's see, how far is that? 45? But how long did it take us to add 45? To get from 10 to 15. We added 45 over 5 terms. What is 45 divided by 5? So we were adding 9 each time. They want us to find the first term again. So we're going to use that same process. I like using u sub 10. So u sub 10 was 25. So 25 would equal the first term plus, what would I be multiplying that difference by? 9 times 9, because our difference is 9. That's going to be 81. And if I subtract 81 from both sides, what's 25 minus 81? Negative 56? Ooh, the next one's worded weird. How many terms are in the sequence 3, 9, 15, ... 81, 87? Do we want to write them all out? You could. What do we know, though? Do you know anything from this list? Okay, the range of the values. Okay, we know u sub 1. U sub 1 is 3. What's the common difference that's being added each time? 6. What is this question actually asking us to find? How many terms are in that sequence? But what does it mean? Which u we're at. So we're trying to find out which position is 87 at. So let's think about that. There's a couple of ways you could do it. One way you could do it is by using the formula. we could subtract 3, right? That would give me 84 equals something times 6. Well, 84 is that difference between the first and the last term, isn't it? And if we divided that by 6, what's 84 divided by 6? 14? So 14 is what we would have to multiply by to get there. So which position are we in? 15. The next one says to show that the sequence is arithmetic. Arithmetic means we're adding or subtracting something each time. So how could I show that it's arithmetic? Show the common difference. So how would I show what the common difference is? Okay. 17 minus 6 is 11. Is it enough to show that the difference between two terms is 11? Or should we show that it works for another set too? Okay, so 28 minus 17 is also 11. Now we can show that D is 11. Find the formula for its general term. That means we're going to write U sub n equals, that's the general term. What do we start with? 6 plus n minus 1 times that common difference. Find the 50th term. I'll let y'all do that in the calculator for me. I did too. How many terms are in the sequence? Which term are they asking about? 908. So we're going to do basically what we just did on this last example. We need to figure out which position 908 is. So 908 would equal 6 plus something times 11. I'm going to subtract 6. So which position is 908 in? 83 terms. Is 325 a member of the sequence? How can we figure out if 325 is a member of the sequence? Plug it in. 325 equals 6 plus n minus 1 times 11. So I got 319 equals n minus 1 times 11. I got 29 equals n minus 1. So it's the 30th term.
But like, how do you know if it's not?
All right. I bet the next one isn't. 761 equals 6 plus n minus 1 times 11. 755 equals n minus 1 times 11. Ooh! What did you get when you tried to divide by 11? Can I have a position in a list that's a 68.6? No. It's between two members.
So there's like a decimal limit.
All right. It's not a member, it's between two members. It's in a decimal position which doesn't really exist in a list. Okay, so we're going to go to an example of how you might see some of these. A free-falling skydiver speeds up as she falls. That means that each second she falls a longer distance than the previous. That should say previous second. It's not a precious second. She falls 16 feet during the first second. So we have 16. Then on the second second it's 48. Then the third second it's 80, and so on. What kind of pattern is this? What's happening each time? Adding 32. So how far is she falling during the fourth second? $112. And then the fifth second? $144. Now let's think about this. How far will she fall during all 5 seconds? So she fell 16 feet the first second. During the second second, she fell another 48 feet, and then another 80, and then she fell a long way. So to find out how far she fell total, you need to add them up. When you add up terms in a sequence, we call that a series. Don't know why, but we do. How did you? So she fell a total of 400 feet. Now, it wasn't too hard with that one because we only had 5 terms. But remember some of those other examples? We had like a lot of terms, like 100 terms and stuff. Would you really want to list them all out and add them up? I wouldn't either. There's a quicker way to add up terms. And I want to show you where the formula comes from. When I have all of these terms in a sequence, and these are a sequence, I'm adding 2 each time. If I take the first term and the last term, what would they add up to be? 20. 3 plus 17. I'm going to take the next group. 5 and 15. 7 and 13. Then 9 and 11. A pretty nifty trick, right? When it's a sequence, the pairs add up to be the same thing each time. How many 20s would I have? 1, 2, 3, 4, 5 of them, right? We have 5 pairs. 5 times 20 would be 100. So the formula you'll see, there's actually 2 different formulas. One of them says I could take the first number plus the last number and multiply that by half of my number of terms. Well, how many terms did I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of that is 5 because they're paired. There is another formula in the formula book. I do not like it at all. There are times where it's useful. I prefer this one. Because it's easy. You take the first plus the last times half of the number of terms. So let's practice using it. See, we're almost done. Find the sum of the first 13 terms in this sequence. So how many terms are we adding up? We need to know the first term and we need to know the last term, right? So the formula for the sum is to take the number of terms divided by 2 and then u sub 1 plus u sub n. This really means we're going to take the first term plus the last term. Pep rally schedule. So we know the number of terms. We know the first term. What's the first term? -5. What do we need before we can use the formula? Last term. We need the last term. So we need the 13th term. I wish we knew how to find a term, a specific term in a sequence. Oh, we do. U sub 13, what would we start with? -5 plus 12 times our common difference. Well, I better find out what the common difference is. What am I adding each time? 6. Twelve times 6 is 72 minus 5. That'd be 65? Y'all check me with the calculator. I'm doing this in my head. Huh? 67?
Oh, wait, no. Wait.
Yeah.
Okay, yeah.
Thank you. Now we can use the formula to find the sum. This big S is just a way to say sum. So the sum of the first 13 terms, we take the number of terms divided by 2, because remember we're pairing them, and then we take the first term plus the last term. Oh, I ain't doing that in my head. I give up on that. 6.5 times. Did anybody get 403? Very good. Now remember, if you were given this on an IB test, could you list out 13 terms in the sequence and then add them up? You could. Once you know the pattern, you could do that. But remember, it is a time test, so the more you learn about the tricks, the better it'll work. Number 2, find the sum of the terms in this series. So this one starts at -14. That's my first term. What's the common difference here? What's being added each time? 6 plus 6 plus 6. That's my common difference. Oh, they didn't tell us how many terms there were. Do we know the last term? We know the last term is 142. we need which term this is. Because, remember, our formula, we have to know how many terms we're adding up. So we're going to use that general form, plug in what we know, and find out how many terms are in this list. So, 142, you'd have to start with negative 14, and we'd add, we don't know how many, D's. And you said the common difference was 6? So to work backwards, we need to add 14. So 142 plus 14 gives me 156. Divide by 6. I should have given more room on this problem. So which term is 142? I'm going to erase this. It's the 27th term? Okay. So now I know everything I need to use this formula. I needed the number of terms, I needed the first term, and I needed the last term. First term plus the last term. Because remember, if we pair them up, they always add up to be the same thing. So 27 divided by 2 times negative 14 plus 142. Woo! Did you get 1,728? All right. And that was 27 terms. I really wouldn't want to list out 27 terms. 13, not so bad. 27, bad. Okay. Ron agrees with his son Brett's request for an increase in his allowance. Poor kid doesn't get any money. Of 75 cents per week for 24 weeks. Poor Brett. Well, maybe Brett's only like 5. Okay, so Brett's allowance now is $3. First week, it's $3, right? Does everybody agree with that? Yeah. Okay. So U sub 1 is 3. That's what we're starting with. They're increasing it 75 cents per week, every week. So my common difference is going to be 0.75. That's what we're adding each time. How much will his allowance be on the 24th week? Well, I could list it out. I could do 3 plus 0.75 plus 0.75. I don't want to do that. I'm going to use the pattern. U sub 24 would equal, start with the first term, plus, remember we've already taken care of the first term, so how many of these D's am I multiplying by? 23. So let's see if he makes any more money by that 24th week. Woo! Go Brett! Score! Daddy didn't know what he was doing there. Now remember, that means on the 24th week, he is getting $20.25. How much has Brett maneuvered out of Daddy over the full 24 weeks? Oh, no, because the first week it was $3. Second week he got $3.75. The next week he got $4.50. So we need to know the total amount. We have to add up all of those allowances for full 24 weeks. So we want to actually know the sum of those 24 weeks. So how many weeks are we counting? 24. We're going to have that because we're talking about those pairings. And we can use the pairing of the first term plus the last term. Whew!
Wow.
Go, Brett! That's a lot of money. I don't know what he's going to buy with all that. But
One of those RC cards.
oh, that'd be awesome. All right. So are we okay with arithmetic sequences?
Yes.
Okay. Not too scary.
Yes.
Yes.